In this video, I'm going to tell you about the pod disruption budget, which is a type of resource in Kubernetes. And what it does is it will limit the number of pods for an application that can be down simultaneously at the same time from voluntary disruptions. Some but not all. I will explain that later. So the classic case is if you voluntarily drain a node. This is very common typically when you upgrade your Kubernetes version, you upgrade the control plane, and then one by one you have to upgrade each node. And part of the node upgrade process, one of the earlier stages, is draining the node of pods, evicting the pods on there. So a pod disruption budget will ensure that the number of pods that are drained are limited, and therefore your app remains available. It's very, very useful. Let me show you how this works in a demo. So here we are, typically again on my own personal Linux server, on which I've got running a lightweight Kubernetes distribution called Kind. You can use Minikube or whatever. I like Kind. And I've created a manifest called demo.yaml. Let's have a look at this. So this manifest contains 3 resources. The first is just a namespace called demo. The second is a deployment. I've used a popular image here just for the sake of the demo. It really doesn't matter what I've used here. The key here is that there's going to be 6 pods, and also I have said that there is a label here called app HTTP echo, key value app HTTP echo. And finally there's another resource, this new one called pod disruption budget. It also applies on that label, that's why I use the label. And we've actually specified here, there's a number of options, but this is a very common option to say there must at all times be a minimum number of pods in the entire cluster of 3. So if I, for example, drain a node, whatever happens, you've got to make sure that there's always going to be 3 pods of HTTP echo application running on the cluster. Now you might think this should never happen if you've got pods running across multiple nodes. Let's say you got 6 nodes, 6 replicas, maybe you got 1 pod on each of your nodes, but it can sometimes happen that you have an out of balance situation and all your pods are just stuck on one node. And if you don't have a pod disruption budget, then when that node is drained and all the pods are evicted, then all the pods for your application will be gone. You'll have downtime, and that's not what we want. So that's why pod disruption budget is super useful. It will say for this app, always make sure that there are 3 available pods when you're draining the node, and don't evict if you've run out of pods to evict. I'll show you now. Let's go do the demo. So obviously the first thing we're going to do is apply this manifest, and there you go, it created those 3 resources. Great. Now let's look at the pods, and you can see here the one running, the rest are still in the creation process. Run it again, still the same, but it shouldn't be long now until we have all running. Great. Now remember, I said that the pod disruption budget won't apply for every single type of voluntary disruption. For example, if I just do a k-delete pod, everything on that label in this namespace, and you can see that they all get deleted. And if I just view all the pods again, they're all of them are getting recreated again. And now we're back to where we were before, but we have 6 completely new pods with different names now. So it will protect you against draining a node, which is the real classic case, but it won't protect you against things like deleting pods. So don't think it's going to protect you against human error. You've still got to be careful when administering a cluster. So let's now go ahead and drain this node. So kubectl drain, the name of the node. It's only a single node, this cluster. This is the name of mine, and here's a common switch to ignore the daemon sets. So let's run this, and you'll start to see a lot of things happening. Now it's also obviously evicting pods that are unrelated to our application. We're going to ignore those, but what I'm going to do is I'm going to press Control-C just to stop this drain, because it's actually just repeating itself now. Let's go up and have a look here. So the key here is the 6 pods for our demo. Unfortunately, kubesystem is in the way, but it's identified pod demo HTTP echo 6 different pods, 4 pods at the top of this block and 2 here. It's identified 6 to evict, which is what a drain is, and it managed to evict 3 of them here, 4LS, DCG and W6B. However, it was unable to evict these 3, WMN, BD and LGR, and it says here, error when evicting pods, cannot evict the pod as it would violate the pod's disruption budget. That's perfect. That's exactly what we wanted it to do. And if you scroll down, then it just keeps repeating itself. It still is unable to evict those pods. And as things stand, it will never be able to evict those pods because it has to keep 3 running at all times. Now, if there was another node that it could magically create new pods on, it would be able to fully drain this node and get rid of all 6 pods on this particular node. But this is the only node, so it's never going to be able to do it. Let me show you. I'm going to run this command now to look at all of our applications pods again, but I've added this switch at the end to sort it by time, which will just help make it more easier to look at. So what we can see here is 3 pods that are running and 3 that are pending. So the first thing to say is that those 3 pods that were evicted, I don't remember the names, but it doesn't matter, they're gone. You can't see them here anymore. They're gone forever. They'll never come back. These 3 that are pending, which you can see are the newest pods because it says have an age of 2 minutes, these 3 that are pending are the latest, the replacement pods for the ones that got evicted. Now, pending means that they actually haven't been scheduled onto any particular node at the time. We're viewing this using a kubectl command, but they're not actually scheduled onto my single node cluster yet. They're just sort of sitting there waiting to be placed on a node. There's only one node, my node, that's available, but because I've drained this node, when you drain a node, the first part of that is actually cordoning it, like putting some police tape around the node to say, I'm draining this node, I'm trying to get rid of all the pods, do not put any new pods onto this node. So they're just stuck in this perpetual state of being pending, unable to be scheduled onto my node, the only node around. They've been given a name already, so they've been registered, if you like, in the cluster, but they're sitting there not existing anywhere yet, not on any node. So those are the 3 pending ones. They're replacements that are due for the 3 that we already evicted. The 3 running nodes are 3 of the original 6. Remember, these are the ones that could not be evicted because of the pod disruption budget, because the pod disruption budget says the minimum available must be 3. So obviously it's seeing these 3 and it's not removing any, because if it removes even one of them, it will already violate that pod disruption budget. So this is exactly the behavior that we want. So finally what I'm going to do is I'm going to uncordon this node. So there's the command, and it's been uncordoned, the tape has been removed. Let's replay that other command, and you can see here, if I just replay this again, because it's been created, now they're all running. So you can now see here that those original 3 that could not be evicted, BD, LGR and WMN, they're still here. They survived. They never ever got evicted. The 3 replacements that were in a pending state, K9, VD and LZ, they're now in a running state. This means that these pods, which were registered in the cluster but had yet to be assigned to a node because the only node available had a cordon around it, well, that cordon has now been removed because we did an uncordon, and those 3 have now been successfully scheduled on the only available node, this single node, and they're now running. Now, just to say, this is obviously a very unique situation. Having a single node, you wouldn't ordinarily do what we've just done, a drain and then uncordon. You would typically be doing a draining and an uncordon in a situation where you're upgrading a cluster. You need to upgrade the nodes one by one. You would drain the node. Kubernetes would schedule new pods onto the remaining nodes, you would take down the node that you're going to upgrade, you would change the image, you'd power it back on, you would then uncordon the node to finally allow Kubernetes to reschedule brand new pods onto that node. That's how it would work. But for this demo, we only have a single node, so it's a little bit of an obtuse situation, but I hope you see it demonstrates what we're trying to achieve here. So finally, I just wanted to say that it is quite common to use the pod disruption budget in the way that we've done to specify a minimum available number of pods or replicas for a given application. But there are other ways that you can do this. You can say like max unavailable, for example. And let me just show you something as well. I've just run a kget PDB, which is short for pod disruption budget, in the namespace demo, and you can see here that it's a minimum available 3 as we've got specified, and it's actually worked out that that means 3 allowed disruptions. It's actually looked at this app, seen that there are 6 replicas in it, and done a 6 minus 3 equals 3. It's actually worked that out ahead of time, so it's ready to apply. And as you can see, this is the other option that I mentioned here. Instead of min available, you can also do a max unavailable if you want. Either way, it's going to work out what the number of allowed disruptions is, and it will make sure to stick to that particular policy. So I hope you found this video useful. If you did, please give it a thumbs up, please subscribe to the channel, and I will see you again soon. Take care. Bye bye.